Notes 27. Continuation of the definite integral. So here's what we learned yesterday. That this guy equals this. That's called a definite integral. There is something called indefinite integral. That's if you don't have limits. We'll talk about that pretty soon. You kind of already know this is the antiderivative. That's kind of my fault. We haven't talked about the fundamental theorem of calculus and why this stands for antiderivative. When we get to that, we'll probably get to it by the end of the week, hopefully. If not the end of the week, the beginning of next week. All right, I have 3 scenarios. So I'm just going to exaggerate quadrant 1. And either I have all my area above the x-axis, so either I have something like this. I'm going to call this A, I'm going to call this B, and I'm going to put a curve just like that. So I have this scenario. If all this area here, that's just this. That's just this. And if I have something like that, it's going to be a positive number. So I'm going to write integral a to b of f of x dx is some positive value. You can have some area above x-axis, some area below the x-axis. So I can do something like this. Now in this case, I'm going to say this is B. In this case, I have more above than below. So it's going to be, the total thing is going to be positive. But you can always have more negative than positive area. So I'm not going to put any sign on that one. And then for scenario 3, you can have all the area below the x-axis. So let me exaggerate quadrant 4. I'm going to put a curve. I'm going to call this A. I'm going to call this B. And this is my area. This is the x-axis right there. And this, from A to B of f of x dx, is definitely negative because it's below the x-axis. That's called signed area. Nothing crazy. How do we feel so far? Okay, nothing crazy, right? Hallelujah. Amen. Oh, okay. Yes. No, I'm sorry, miss. Okay. Nothing crazy, nothing that's like wow. Again, we're just reiterating, this is just the same notes from yesterday. And I don't have to put it as an X. I can write it as a letter. I can toggle the letters. I don't like to say this one because, you know, it's very careful to say something we don't want to say. F of X, yeah, I'm not going to say F of T and whatever, you know, but okay. These are the rules. And don't worry, we're going to talk about why these rules exist. And as a matter of fact, I left some space down there to talk about those rules. Okay, don't worry, we're going to talk about all of them. So, order of integration. Notice, I don't like the way they did that, but that's fine. I like to make the lower limit an A, the upper limit a B, and then they switched it here. It's okay. So, number 1. Do you want me to, I'm just going to do it my way. Integral A to B of f of x dx. That means this. I'm just going to make something up. I'm going to put it all above the x-axis for now, guys. So the way you read this, you start at A and you stop at B. If I reverse it, so let's think about it. If I reverse it, now I start at B and stop at A. And now look at this graph. Right now, B minus A is some positive number. Do you agree? But what if I reverse the order? What if I go A minus B? Will that be a positive number? No, that would be a negative number. Do you guys see that? So if I reverse the order of this integral, then this must mean that I have to put a negative on the outside because now I'm counting backwards. Does that make sense to you guys? Nothing crazy, right? Okay. Letter B, 0. Well, yeah, look, okay. Y, look. A to A of f of x dx is 0. Well, that's because look where you start. You start at x equals A and you stop at x equals A. Have you moved? No, so that's literally you're just on this line and you haven't accumulated any area. You're still there. Does that make sense? Does that make sense? Delgado? Okay. I know, miss, I know. You're probably tired. What time do you go to sleep? 3 in the morning? No? Oh, okay. Never mind. All right. The constant multiple. This is just like limits. If you have something like this, so number 3, I'm going to put it right here. If you have something like a to b, and then I have a k f of x, where k is a constant, you can just move it to the front. That's all that means. K integral a to b of f of x dx. And I know some of you guys are visual learners and you want to figure this out. Like, why? Why, Chop? Okay. So, do I have margin up here? Yeah, I do. So check out this margin. What's the easiest shape to get an area of, like rectangles? Okay. So I'm going to make this rectangle. I'm going to say that's 0. I'm going to say that's 2. And I'm going to say that's 3. So right now, and I'm going to call this f of x. So right now, integral from 0 to 2 of f of x dx. That's just one large rectangle. That rectangle has what area? 6. Easy, right? You know what? As a matter of fact, I even know what's the equation of that line. It's just y equals 3. So f of x equals 3. So let's say I do this. Integral. And I'm going to put, what's a good number? 4? 4 f of x dx. Okay, well, what is 4 times 3? Because my y value, this is like y equals 3, right? 12. So imagine now I have, here it is. It's not to scale. I have a 12 there, 0 to 2. So this is like saying integral, and I'm going to call this g of x. Integral of g of x, 0 to 2. Well, look what happens. All you're doing, what's 12 times 2? 24. Well, look, that would have been the same thing. What is 4 times 6? 24. Do you see how that just works? Okay, so if you have a constant, you can do that. You can do that. So, yay, we got that. And of course, the rule about interchanging your a to b, b to a still exists. Here is k is equal to -1. Sum and difference rule. Okay. That's kind of the same as limits, but we'll talk about it. I'll talk about it here. So I'm going to go ahead and make this up again. So I'm going to go ahead and, you guys like the 3, so I'm going to keep the 3. So I'm going to call this f of x, and then I'm going to call this one another rectangle. I'm going to call this one g of x. And I'm going to put, what's your favorite number? 5? Okay. So that's the AP score we want. Okay. So what this is saying that if I have something like this from 0 to 2, notice both have the same thing, 0 to 2, f of x, how did they write it? Yeah. If I have something like this, f of x plus g of x, with a dx on the outside, this is saying that I can just go integral 0 to 2 of f of x dx plus integral 0 to 2 of g of x dx. And of course, vice versa as well. And why does it work? Well, let's see. F of x here is 3, f of x here is 5. Right now, this area, 3 times 2 is 6. Right now, this area, 5 times 2 is 10. And together, those areas are 16. Do you guys see that? Now look, check it out. That's a 5, that's a 3. If I add 5 and 3, that's 5, 6, 7, 8. So that's 8. And now here I am at 8. 0 to 2. Did I add that correctly? 5, 6, 7, 8. 16. Yep. Look, 8 times 2. What's 8 times 2? And I still have that area where this guy is f of x plus g of x. That's that new line. Here's my grid. I know I'm writing all over the place. Does that make sense, guys? Yeah, I'll slow down because I can see some of you guys are looking kind of funny. All right, let me say that again because I feel like I did a bad job there. So here's f of x, and this is the line y equals 3, or f of x equals 3. Here's g of x, and this is the line y equals 5. Yes or no? Area under the curve of f of x, well, that's a 3 and that's a 2. From 0 to 2, the area is 6. 3 times 2. Right? The area under the curve of g of x from 0 to 2 of 5, well, 5 times 2 is 10. So this guy right here, I'm just adding f of x plus g of x. So this, according to this, 10 plus 6 is 16. Right? That's my rule. And so here, this guy, this little integral right here was a 6. This little integral right here was a 10. And yeah, 6 plus 10 was 16. And then can I do it as a one integral? Yeah. The function f of x plus g of x is, well, what's 5 plus 3? 8. So if I were to call this, I don't know, you can call it h of x if you want. H of x equals that or whatever. If I were to graph just 8 from 0 to 2, notice you still get that number 16. Do you guys see that? So I can have different integrals as long as the limits are the same, the corresponding limits, and you can add them together or subtract them as well. No, Yanni, that's a demerit. The next one's going to be right to Montalongo's office. Hey, Montalongo, if you're watching my YouTube video, books. I'm just going to make something up. -3 to 0. What happened? Oh, yes.
Maybe I'm tweaking, but I don't know if we went over the last one.
Oh, yeah. Additivity. Okay.
You might not want to mark it anymore.
Yeah, we'll see. Okay, here we go. Additivity. Tell me if this makes sense. A to B to C. Okay, got you. Here is A. Here is B. Here is C. And I'm going to call this f of x. Huh? I'm going to color code it. All right. So if I do this, if I go integral from a to b of f of x dx plus, where that one stops, the other one begins, integral from b to c of f of x dx, will this give me the area under the curve from a all the way to c? Yes, that's all it is. A to c of f of x dx. So notice from a to b, from b to c, and all that together is just a to c. All right. Here we go. Ready?
No.
Oh. All right. Yes, that's it.
No, I know that.
Oh, yeah.
Yes.
Okay. No. Hit me. Ask me. Yeah. Hell yeah, I can go back. What's up? I didn't say anything back. Yes. So check it out, Espinosa. So if I add this stuff in sky blue from A to B, and I add this in burnt orange from UT Austin from B to C, is that the same thing as this that I'm shading in black from A all the way to C? Yeah, that's all. We're just adding the stuff in sky blue and the stuff in burnt orange. And we're saying that we can just write it as one integral from A to C. Okay, perfect. Okay, here we go, guys. Focus. All right. I have some curve. I have no idea how this curve looks like. And all we know right now is that this means area under this curve is square root of 2. So all this right here, I start at -3, I stop at 0, and the area under that curve is square root of 2. Cool or not cool? I'm using the properties that they told me. So here we go. Notice, look what they're doing. Where are they starting for letter A? They start at 0 and they end at -3. So what am I going to get as an output? Negative square root of 2, because you're counting backwards.
Oh, yeah. Wait a minute. Oh, yeah, because you're going from 0 to I read it backwards.
All right, here we go. All of a sudden, they change the letter to a U on I'm on letter B. Is that going to change the output? No. It's still going to be square root of 2. Doesn't matter what axis you call it. You can call it the V axis. You can call it your mom axis. It doesn't matter. All right. Here we go. Next one, letter C. Notice what I have inside is going from -3 to 0, but I have a negative on the inside. Can I pull that negative out? Can I say that's like a -1? Yeah, you can. You can say that's like -1 integral -3 to 0 of g of x dx. So this is going to give me what? Negative square root of 2. Cool or not cool? Look at letter D. Don't freak out just because there's a quotient there, guys. This is like a constant. And you can rewrite this as -3 to 0. Let me put it in here in the front. 1 over square root of 2 g of r dr. Is anyone confused by what I wrote? Yes? Okay. Let me slow down then. Okay. Yes. Look, I could rewrite this, guys, and I'm going to rewrite it in several steps. I can rewrite this as 1 over square root of 2 times g of r dr. Yes or no? Is 1 over square root of 2 a constant? Yes, it is. So I'm going to put it outside the integrand. So 1 over square root of 2 integral negative 3 to 0, that's how you say it, of g of r dr. So 1 over square root of 2 times, what's the area of the curve from negative 3 to 0? Square root of 2. What's 1 over square root of 2 times square root of 2? 1. Not Juan, but 1. I used to have a kid named Juan, and I'll stop. I hope he's doing awesome. You know what? I'm going to reach out to him. I hope he's doing okay. Cool or not cool? All right. Let's keep going, guys. Relax. We're going to go slow. So these are areas under the curve. I have no idea how these curves look. Matter of fact, I'm not even going to bother or entertain to try to draw that. You'll see why. Because in a little bit, we're going to get kind of tough, and we're going to see if we can figure these things out. Are we still okay? So they're telling me I have two curves. I have f of x and I have g of x. From 1 to 2 of f of x is negative 4. From 1 to 5 of f of x is 6. From 1 to 5 of g of x is 8. Nothing crazy, right? Letter A. Notice the lower limit is 2. And what is the upper limit? 2. Have you moved? No. You have not moved. What is this going to output? 0. Are we still okay? Okay, look at letter B. Notice the lower limit is 5 and the upper limit is 1. And this is the area under the curve of g of x. Do I have from 1 to 5 of g of x? Yes, it was 8, but now they reverse the limits. That's what we call the upper and lower. We call them the upper and lower limits, not to be confused with the limit of LIM, what we did in Unit 1. Upper limit is 1, lower limit is 5. So because they reverse the order, what is this? Negative 8. Are we understanding this, guys? Okay. Go to the next one. Letter C. I have a constant in front of that f of x. Can I pull it out? 3 integral 1 to 2 of f of x dx. Do I have the integral from 1 to 2 of f of x dx? What is it? Negative 4. So I'm going to have 3 times negative 4. What's going to be this output? Negative 12. Are we still okay, guys? All right. Look at this next one. Don't freak out. Yeah, don't freak out. It says from 2 to 5. Chav, I don't know if I can figure that out, Chav. Look, guys, let me draw a picture for you. It's not, warning, I'm not drawing this picture with a negative 4 and 6. I'm just drawing a picture for conceptual reasons. So I'm going to put NTS, which stands not to scale. I guess I shouldn't be talking about not accurate. I'll just put not. You know what? It doesn't even matter. All right, here we go. Yeah, just 1, 2, 5. Yeah, just listen. Look, it's going to be simple. 1, 2, 5. You know what? NTS, not to scale. Okay, here's f of x. Are we still okay? Nothing crazy, right? So tell me, if I find this area in sky blue, because I do have it from 1 to 5, I see it right here. If I find this area in sky blue and I subtract this area in burnt orange, will that give me the area from 2 to 5? So look what I just did. So let me write it out here. This is not to scale. So what did I just do? Here's what I did, guys. I took the area from 1 to 5 of f of x, and I subtracted the area from 1 to 2 of that same function. And that will give you, what will that give me? The area from what to what? 2 to 5. Do you guys see that? All right, what's the area from 1 to 5? 6. The area from 1 to 5 is 6 minus, I know you're probably already giving me the answer. What's the area from 1 to 2? What do you get? Which is the area from 2 to 5 of f of x dx. Cool or not cool? Okay. Go to the next one. Relax. Relax. You gotta check if you have both those limits on the same, on your f of x and g of x. I'm talking about letter E. Do I have 1 of 5 of f of x dx? Do I have 1 of 5 of g of x dx? So can I go ahead and do this? Yes. So this is nothing more than, let's see, 6 minus 8, which is negative 2. Cool or not cool? All right, let's see. Do we have 1 of 5 of f of x and g of x? Yeah, so this one we can do again. So this is the same thing as going what? 4 times 6 minus 8. What's that? 4 times 6 is 24 minus 8, 16. How do we feel? Okay, let's keep going. Not all of them are possible. Yeah, we're just doing more practice.
So if it's not possible, do we write
Not possible. All right, here we go, guys. Here we go. Area under the curve from 4 to 1 is, can I do that? Yes. What is it? 2. That's it. This one says area under the f of x curve from negative 1 to 4. Can I do that? Yes, you're going to have to go from negative 1 to 1. And then wherever this one stops, the other one better begin. So 1 to 4. Do you guys see what we did? So that's a 4 there. So that's going to be, let's see, 5 plus negative 2. So it's going to be 3. Cool or not cool? All right, what about this next one, letter C? Do I have negative 1 to 1 for f of x? So it's going to be 2 times 5 plus, do I have negative 1 to 1 of h of x? So 3 times 7. Let's see. 10 plus 21. So it's going to be 31. Cool or not cool? All right. Do I have enough information for letter D? No. Not enough info. Now we got to be careful. So let me go ahead and tell you the careful part. If they would have told us that f of x is even, then we would have enough information. Do you remember what an even function is? It's symmetric about the y-axis. But they didn't tell us that. So we're good. All right. Yeah, because if they would have told us that f of x was even, well, from negative 1 to 1, it's 5. So you would just cut it in half. Does that make sense? Here's what you're like, what are you talking about, Chav? Okay, let's say they would have told us this. So here it is. I'm creating this graph. That's an even function. Negative 1 to 1 because it's symmetric on the y-axis. You guys see that? So what if I told you all this area here was 5 in black? So then do I know the area from 0 to 1? Yeah, you just split it in half. It would be 5 over 2 or 2.5. But that's only if they told you that it's even. Did they tell us that? No. Okay. Let's,
So if they say that like f of x or whatever it is,
an even function? Yes. It's not. It can't be odd because if it was odd, negative 1 to 1 would be 0. All right. Letter E. Negative 2 to 2. Do I have enough information for that? Nope. You don't have outside the interval between negative 2 and negative 1 and 1 and 2. Not enough info. And letter F, negative 1 of 4, yes for that guy, but not for, do I have enough info for letter F? No. Which one is stopping me? The h of x, not enough info. Cool or not cool? All right. Look guys, we're almost done, and then you guys will know enough to take care of the UH quiz, yeah. The regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 18, so this is 18. The area of region B is 14, so this is 14. And the area of region C is 8, so this is 8. What is the value between negative 5 and 8? So here's negative 5, and here's 8. So they're talking about the signed area. If they don't tell you anything, that's what they want. From negative 5 to 8 of, what is this, graph of that? f of x dx. Well, is region A below the x-axis? Yeah, so that's going to be a negative 18. We're talking about signed area. Plus, is region B, because they want from negative 5 all the way to 8, so they want all this regions. Plus negative 14. And then what about region C? It's positive because it's above the x-axis. So this guy from negative 5 to 8 of f of x dx is nothing more than, let's see, negative 18, 28, 1 to 2. What is it? Negative 24? Negative 24.
What's signed area?
Oh, signed it. Well, area itself can never be negative. So because you're below the x-axis, that's why I called it signed area. Does that make sense? Yeah. The area itself can never be negative, but because it's below the x-axis, we're going to call it negative. How do we feel, guys? Okay, we should know now enough to cover, it's called UH Quiz 22, Riemann, sums, and integral properties. Well, let's make an attempt today and do the Monday, which is a what day? The 29th. Can we do that, guys? All right, we're done, guys. Good job.